Hello, the Internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions. Co-hosting with me today is Carol.
Hi, folks. I'm Carol Willing. I'm an active member of the Jupyter and Python communities, and I'm very happy to have an opportunity today to chat about Chainer with Chrisman.
Hi, I'm Chrisman. And I'm an engineer working with the CUPI and Chainer teams at Preferred Networks, which is an AI startup. And you might not know due to the magic of the internet, but I'm broadcasting to you from Tokyo, Japan.
Excellent. Well, thanks so much, Chrisman, for joining us. I'm very excited to talk about Chainer today. But before we do that, we're going to do our famous Tweet of the Week section, where each of us gets to present a tweet that we've been enjoying recently. So, Chrisman, you are first up.
Okay, so I'm going to make sure that I know how to use the sharing system here. So this is the first tweet that I found. And I love the adversarial examples, the how to make a banana look like a gun or the other things. And this is an adversarial example of how to hack an automated evaluation of essays. So,
wow.
That's great.
So this is from Ben Zimmer. They basically reverse engineered what's used right now for grading the GREs. It's an automated essay scoring system.
Mm-hmm.
And just to start out with it, the reading goes, history by mimic has not, and presumably never will be, precipitously but blithely ensconced. Society imaginativeness, many of scrutinizations, but a few for an amanuensis.
pure comedy gold right there.
There you go.
I love reading it with a dramatic voice. Is it the deep meaning for this, and which indeed the automated scorer says, yeah, that's a fantastic, very very deep essay.
That's excellent.
So
yeah,
go ahead.
Yep. Anything else you'd like to share? Or...
Sure. Let me jump to the other one that I found today that I thought was also really fun. So you have to disable, and then we'll just enable this again. So in the Japan office, I'm oftentimes the go-to for what does an English word mean. And oftentimes we have this kind of a situation where I'm like, well, what does it mean, really? You can see 613 votes. I guess the rounding put it back to exactly 50%. So oftentimes when I'm trying to explain what English words mean, I find that I really can't explain it either. And I thought this tweet really caught well the dilemma that I had inside of my office trying to explain my own language.
That's a riot.
Yeah, that's a riot. That's incredible.
Actually, I think the dictionary has both definitions in it, just to really complicate things. But
yeah,
right. But if you wanted to know which one's more commonly used,
I don't know.
Yeah, I feel like this happens with various spellings a lot too. There's certain words where you can spell them a couple of different ways, and neither one is necessarily correct per se.
Right. We oftentimes have the same issue with pronunciation, and my pronunciation is largely book learned, is usually the wrong one. Like that's my default is, okay, if someone else pronounces it differently, mine's probably
right.
Ever since I told my mother when I was a child, what do you think I am, knave?
Yeah. So you say bi-monthly? Is that No.
Yeah, chasm.
Yeah, chasms. There we go. That's great.
Right.
Well, Carol, do you have some tweets for us?
Yeah, it was a close call whether to do the Pi tweet from SimPi, but ultimately I went with a project called Black, which is its happy first birthday. So they had cake instead of pie. And the tweet was just saying, last year, if anybody had thought about what Black was going to do in terms of helping Python formatting, we would have thought, whoa, but it's now the last beta and heading towards, full release. So it's pretty cool.
That's excellent. Yeah. Black is a great tool. For my tweet, I'd like to quote Grant Sanderson today, who says, Ah, Pi Day. When non-Americans everywhere, what on earth Pi has to do with 14.3? So, so true. All right, well, we'll go ahead and wrap that up and dive on into a brief project introduction to Chainer. So Chainer, if you don't already know, is a flexible and intuitive framework for neural networks, and it leverages CuPy, which we've previously discussed on this show, for calculations on GPUs, if you want to use it in that way. It's got about 4,600 stars on GitHub currently, and gets about 30,000 downloads a month on PyPI, which is pretty great. So,
which is pretty healthy.
Yeah,
so,
very healthy.
So, Chrisman, why was the project started, and what needs does it need to fill?
Well, it was Chainer was written back in June of 2015. At the time, the existing deep learning frameworks was basically Theano. And so it was one of the first ones really to be focused into the Python language and to give the define by run system, which meant that instead of having sort of a pre-compiled neural network, as the network was executed, it would be interpreted at that point. Later, this approach was adopted by PyTorch, and recently TensorFlow is going to be making it the default version in TensorFlow 2.0 as eager mode. So it was to make it easier to do deep learning calculations and implement deep learning neural networks so that you could let more of it be done by the back end and just focus on the models as a researcher.
Excellent.
Awesome.
Yeah, that's great. Are there alternative projects out there to Chainer?
Yeah, fortunately the market's fairly busy. So there's Google's TensorFlow, I think, is the best known. Then Facebook's PyTorch is also quite popular. And we all borrow from each other. Chainer was the first one to do the define by run. And of course, we're continuing, as we'll be talking about later, to push into new areas to make it more easy to do neural network coding in Python and other languages.
Very cool. Well, we know this is an area that's moving fast. So maybe you can share what technology Chainer is built upon.
So Chainer's, it's pure Python, although we're now moving towards some C++, and we'll talk about that some more in the roadmap. So while the other languages, I'm not like TensorFlow, I have to admit, I'm much more familiar with Chainer than I am with TensorFlow. TensorFlow feels more sort of C, especially in the interface, and it was pre-compiled, although they're moving towards a more Chainer-like system. And then PyTorch was originally based on Lua, on Torch with Lua.
Right.
And they're also moving more towards a pure Python and C background. So the industry in general, the Python is agreed upon pretty much as the best way for doing fast development of something and for doing trials. It's very intuitive. And then for the back end in the long term and for speed purposes, you want to move towards a C++ kind of environment.
Yeah, that totally makes sense.
Excellent. And who started Chainer originally?
It was a Japanese, one of my colleagues here in Preferred Networks named Seiya Tokui, and he wrote it. It was actually his third attempt at making a deep framework.
Wow.
He wrote it over, there's a long vacation in Japan where they have about a week worth of holidays in May over Golden Week, and it was just over Golden Week that he, the third time was the charm that he banged out Chainer, and that was the one that really took and has gone from there.
Very cool. So now we know who started it. Now who's maintaining it on a regular basis?
It's still, Tokui-san's still the head of the maintainer. We have a team of people, of about 6 people here at Preferred Networks, including myself, who work on maintaining it and going through all of the issues and making the roadmap, filling out where we want it to be continue to be the best tool for researchers to use for deep learning.
Excellent. So do most of the contributors and users come from a research background, or where are folks coming to Chainer from?
Well, the people that I'm most familiar with is actually the people here inside of my own company. We're strong believers in using our own product. And Preferred Networks is a large company here in Japan, but less known overseas. We focus on industrial deep learning. So we do automated self-driving cars for Toyota. We work on robotics, both for FANUC, which is a big industrial robotics thing, as well as we just recently started working on our own personal robot.
Wow.
And we do a lot of competitions and other things. So everything that we do internally, we use Chainer for. So it gives it quite a breadth. Outside of that, it is mostly researchers we find who notice about Chainer and start using it because of the very intuitive interface and the ease of getting in and being able to work basically with the code all the way through, since it's nearly 100% Python at this point.
Very cool. Well, I know that there's a lot going on. Is there a community or group that typically contributes to Chainer?
Sure, we have a lot of there are a lot of people using it in Japan. It's one of the main frameworks within Japan, and outside of Japan, we're getting more people who are interested in it. This year we've joined NumFocus. Actually, it was just December of last year. So it's good to be under the umbrella of NumFocus as an open source project that's growing and attracting more users. And also this year we're participating in the Google Summer of Code. And so we're getting much more international interest in contributing to Chainer, and which is great. It moves us more into a maintainer sort of position where we're reviewing code and making sure that it follows the vision as opposed to driving it ourselves. So we've had lots of functions which have been introduced by other people and other functionality which is being brought into Chainer, which is great to see.
Great. Well, since it is a project that is not hosted in the US, and part of projects are getting a global group of people using it, are you guys doing anything in the diversity or inclusion area to get more people contributing?
Yeah, that's something we're always interested in. I think we share that with most open source projects. The more people that we had using it and developing, the better off it would be. From the Japanese point of view, at least, for the people here in the company, Japan's a very homogenous culture. About 99% of the people in Japan are Japanese. So the diversity actually comes from people like myself. Foreigners, I'm well in the minority here, although my company has more foreigners than most Japanese companies. And so we're always interested, although as an open source project, we don't have the ability to pay people in general. And so it's whoever is interested in coding is welcome. Sounds
great. Sounds great. Okay, are we getting down to the demo stuff?
Yeah, I think so. I think at this point, if you could show off some of the fun parts of Chainer, that'd be excellent.
Okay.
So if you've got a demo on Colab, I believe, right? So and get that over to folks.
Yeah,
perfect.
So this is a basic demonstration of how to use Chainer, and to just show how intuitive it is. I like to start out with the basic picture of sort of just how the blocks fit together, because when I first started looking at Chainer, the various pieces that fit together, once you see the big picture of how they fit together, it becomes very straightforward to use. So I'll just go through this to give an idea of how it fits together. There's the basic installation of Chainer. It's available on Conda, as well as just pip install. And we'll go skip past this stuff so we can start talking about the data set. So in the data set, then, basically a lot of stuff is available as a simple download. In this demo, I've chosen to use Fashion MNIST because I think many
very cool.
Yeah, many people who've done a few deep learning trials have seen a lot of MNIST, which is basically a data set of just black and white numbers. But that is now, I think, 20 years old or so. So as a data set, it's quite old, which is not a problem, but more so is that it now is too simple for most deep learning networks. At the time, it was a difficult challenge, but then Fashion MNIST can be used as a drop-in replacement for it. And as you can see from the t-shirt that I have displayed here, is a little bit more tricky to identify. This is just one of the things. It has basically 10 articles of clothing that then are the things that you need to classify.
So it's actually classifying the clothing, not the logo on the shirt?
No, there's no specific logos. This was from a German fashion company created the data set, which I thought was
very cool.
some interesting form of marketing, right?
Yeah.
Right. That's awesome.
So you can see at the top there's a list of the labels. There's t-shirts, trousers, pullovers, dresses, coats, sandals, shirts, sneakers, bags, and ankle boots.
Right.
And one of the difficult ones, for example, is the ankle boot versus sneaker.
Mm.
Okay.
All right.
Right. So then after we've loaded in the data set, then that's fed into the iterator then, that's just going to take your data set and farm it out into batches.
Mm-hmm.
And one of the other things I like to emphasize here is that it's important to make three iterators, and because you want to have 3 test sets. You need your training set where your data set will learn it. You need your test set, which is the ultimate validation of what your performance is. And then you also need a validation set. Mm. Lots of time, I know it's easy to just forget that as you try different models, optimizers, hyperparameters, and other things, it's easy to forget that if you do all of that straight against the test set, basically you can be learning the test set as opposed to using it to test. So it's important to make a validation set as well that can be used then to make sure that you're not just memorizing your testing set as well.
Yeah, I feel as though many examples don't have a validation set.
I was going to say the same thing. I think a lot of times they just go with the 2, but it actually makes a lot of sense to have all 3.
Right. Yeah, it's a lot of the studies nowadays work for very high benchmarks. So trying to get the highest benchmark, of course, is the easiest way to try and say this is a worthy approach. But if it's not rigorous on the validation set, then it might not be actually a significant improvement. We've had several papers recently which have said actually you could do everything you wanted with an RNN, or you could do everything you wanted just with if you didn't tune it as much with a CNN or other things versus the newer approaches.
Interesting.
Yeah.
So I'll jump down to the actual making of the model, and this is actually quite short here. The model then is a different fork here. So I'm using the sequential in the definition of MLP. Then I use a sequential model to make this easier, and this is a simple 3-layer deep, 100 node wide. And one of the things I really like is that Chainer, because it's defining by run, is able to basically fill in all of the feeds into the layers automatically. So as opposed to saying this many nodes in, this many nodes out, this many nodes in, this many nodes out, it reads automatically as you're going through it how many nodes are going in, and you just tell it how many nodes you have there. So naturally, with this kind of a classifier, you have 127 or so, 128 or so inside of the picture in the grayscale, but you don't need to tell it any of that because that will be interpreted as it runs through and creates the model for you while it executes.
Oh, interesting. Okay.
So the layers then just, it says make a linear layer with 100 nodes in it. And then for an activation function, we're going to use relu, standard. And then we repeat that layer 3 times. Mm-hmm. And then on the end of it, to get to our classification, we're going to have 10 nodes for the classification. And so you just append a linear to the very end of it. And then to get a look at what it looks like, you flatten the network structure, which then takes the repetition layers and makes them into individual layers. And we put our model loss on it as a classic classifier. At this point, you need to tell it whether this is going to be on the GPU or it's going to be on the CPU. Chainer is very strong on the GPU, as the modern frameworks are. And we've done a lot of work, especially with NVIDIA. I'm going to the NVIDIA conference next week, actually. And we have on the back end of Chainer, we have CUPI, mm-hmm. which is basically it's a drop-in replacement for NumPy that enables all of the calculations to follow NumPy syntax. Mm-hmm. So on some of the other frameworks, you'd have issues where sometimes the axis would be axis and of a matrix would be axis, and sometimes it'd be ND axis or dimension or other things, whereas Chainer strictly follows the NumPy syntax.
Right, and we have a previous webinar on that, so you can go watch that one on YouTube if you want to learn more about CUPI.
Yes. So we'll go ahead and we'll do this on the CPU, just using the Colab. MNIST doesn't make that much of a difference. And then the next thing to do is take your model and put that inside of an optimizer. So then the optimizer is basically the way you're going to be computing your loss for the model. And this is just one line, so it's kind of lost here almost between the pictures, because the optimizer, then we just use Atom for an optimizer. You could use stochastic gradient descent or anything else. Set that up on your model loss to do the calculations. So then both of these pieces, the iterator and the optimizer, building, go inside of the updater. And so the updater then is going to be responsible for taking these two pieces together. So you have your optimizer of how you're going to be calculating a loss, and your iterator, which gives the batches. And these two can be put into one updater. And again, we just have one line here that's sandwiched between the two diagrams to make your updaters equal to the training standard updater. There are other updaters for using multiple GPUs or multiple nodes or other things. And we just use the standard one here so that that calculates the loss over each batch.
Got it.
Excellent.
Okay. And so then inside of this, as the training's going on, you're going to want to have statistics and models and other things to see exactly how that's fitting together, whether you're overtraining or undertraining, and see how your training is going, whether you want to quit early or other things. So these are then input as extensions, which are then also rolled into the trainer. So we have the trainer then has evaluation, has extensions which can show you graphs for your loss, give you a report as it's going through, so you can see your validation loss and your main loss on the training segment as well as it goes through it. And I'll be showing off some of these as we go through afterwards. And then once you have these things built into the trainer, it's just a simple trainer run. And I'll save you from watching all this live here. I've run this earlier today, so we don't need to wait online. And you can see that the accuracy here in the validation loss is getting pretty low. The accuracy in the main thing is getting to almost 95%, but in the validation, it's still at about 88%. And this is due to the fashion MNIST being somewhat more difficult, actually, than MNIST. And MNIST, you could get to 99% or 98%. But the fashion MNIST is a little bit more challenging.
Yeah, that extension system seems pretty cool.
I was thinking the same thing, because it kind of bakes in a lot of the stuff that you would want.
Is it pretty easy to write your own extensions and then plug them in? Is that sort of the point?
Absolutely. We have templates for that are available, and in the documentation for Chainer, there's a place where it lists exactly how to put together your own extension to do something additional if you want to.
Oh, that's awesome. That's great.
That is awesome.
Yeah.
Yeah, so then the extensions, here's one of the extensions, which is actually showing you basically the picture of what your network looks like.
Oh, nice.
That's great. This is cool. Yeah.
Yeah.
Right, so then you can actually see how the linear functions are coming together. You've got your 100 nodes, your 784. These are the bits of the picture then coming in with your weights and biases. Right into the linear function then, and that's combined. And then you see the ReLU acting on that. And then again, you go and we have the second layer again with the weights, and this is times it's 100 in to 100 in, and then a linear function again through a ReLU. And then one more linear function, then that comes out into our classifier down at the bottom, which is using a softmax cross entropy as the default for a classifier that then gives you your float at the end answer that basically gives you a likelihood for each of the 10 categories.
Right.
That's awesome. That's cool.
That's neat.
Yeah, so that's helpful for this. And of course, you need to have your validation loss and your main loss. So we can see on this picture, as you might have guessed, since we were getting close to 95% accuracy on the test, the training set, but the validation was sticking up higher, you can see that we're overtraining here. It's just doing a great job, but the validation set is saying, no, not so much. Right, and then you can see that again as you look at the accuracy, that basically while it's continuing to overfit on the training set, it's not being able to generalize enough into the validation set. So in order to, there are obviously ways that you could attack this then to continue the training. You could, we have a package called Chainer CV for computer vision that is available then that adds more tools for using CNNs and other visual applications. It has pre-trained models as well that you can use, as well as the ability to import cafe models, because they have a lot of library of already pre-trained cafe models. And those can be brought into Trainer then to do additional training afterwards for fast results on those.
Wow, yeah, it really seems like there's a whole ecosystem of tools and capabilities around Chainer and using Chainer. That's awesome.
Yeah, thanks. It's because of the diversity of activities that we do here, as well as just the interest that we have in a lot of things. There are a lot of papers that are published using Trainer. We've had the opportunity to push it in a number of different directions. There's the computer vision. Then also we have reinforcement learning. We have a GUI for it, available for it as well, that can then show some of this stuff live and allow you actually to manipulate your training from the GUI.
Oh, that's awesome. That's great.
Right, so you can say, that's not going anywhere. We're going to stop that one, and then, okay, we'll continue to cook this, push this one off as well. And we've also have, this is not specific to Chainer, but we also have recently released a tool called Optuna for hyperparameter optimization, which is another application that can be used with Chainer as well, and also has a similar define by run. So it will terminate unpromising threads and lets you focus on do automatic tuning of the hyperparameters.
Oh, that's
cool. Nice. Yeah,
that's really nice. Yeah.
So that's a quick run over the tutorial. I think I have a link actually of the full tutorial, which is over an hour long, going through this, that I presented a little while ago at EuroSci-Fi. So if you want to take a look at this more in depth or get some of these links, that's available for whoever's like to.
Yeah, excellent. Thanks so much for sharing. I think, yeah, that was a really good kickstart into Chainer and what it's capable of doing. So at this point, we're going to go ahead and talk about the Chainer roadmap and sort of where Chainer is going and what cool things you'd like to see in Chainer in the near future, given time and materials. And just, for everyone out there, these are places where you could jump in and help Chainer, or if you have funding and you'd like to fund Chainer to do some of these activities, these would be great activities to fund as well. So, yeah.
Yeah, so Chainer, as I said, the first one really with the define by run approach or eager mode. So that was several years ago, and we haven't been standing still since then. So we're currently in the beta release for our next generation of Chainer, which is called Chainer X. So Chainer X was created actually as we were looking at where the bottlenecks are in deep learning and machine learning training. Originally, the GPUs really were carrying the day, and they were when they came in, they were the most important thing. And honestly, the CPU, even using Python, was fast enough that the limit to faster progress was waiting for NVIDIA to come out with a new chip or a better accelerator for it. Mm-hmm. So at that point, it was fine for us to use Python for all of the overhead, but Python's going to be generally slower than a compiled language like C. So looking at the trends, we realized even with the Volta, like around last year, that we were nearing 100% utilization on the CPU. So in order to make sure that as the GPU became faster, we didn't want the CPU to become a bottleneck. So over the last year, we've been in stealth mode until our release actually just a month or so, our announcement just a month or so ago. We've been working on a new backend for Chainer that allows for C++ compilation in Chainer as well. And the X actually stands for extensible, accelerated, and exportable.
Accelerated, I like it.
Accelerated.
There's a bit of fun there to make the letter work. Yeah. So it clearly provides the acceleration. We're seeing about a 7 times acceleration when we do like a very CPU-focused computation over existing Chainer Python code. We're already seeing a 7x speed up on CPU calculations.
What are you writing? Like, what does that technology stack look like? Is it C++ with Python bindings? Are you using libffi? Like what's going on here? Yeah.
It's Python bindings.
Okay.
Yeah, so it's basically we're going to put it into we're putting it into the Python bindings so that we want to make the transition smooth and still allow people when they're doing research models or trying to bring in new technologies. We want them to be able to work in Python.
Sure.
Because of the speed of development, at that point the key thing is your developer time, but be able to give the speed of C++ and background. So we have a chainer on chainer X is one of the execution modes available, where then it's just using the Python backgrounds. And it has a natural fallback to the existing Python code if a function hasn't been implemented yet into the C++ libraries.
Right. I mean, it looks like the designs have been really kind of modular, yet you can extend it. And I think one of the nice things when you were saying, Python on the front end, if you're running stuff and this isn't the one that is going to be the chosen one with the hyperparameters, you can just say, okay, we're going to throw that one away. It makes it really powerful, I think, for folks that are using it.
Yeah, it's we really, as a research organization ourselves, it's something that we really want to make available. We've done a number of things to focus Chainer so that it can be used in competitive areas as well. We enter a number of competitions. So they just last year, at the end of last year, we had the Google Images Challenge.
Oh, really? Tell us about how you guys did.
Well, we're very proud. We have a team that's focused on the Japanese translation, I guess, would be the super image team.
The super image.
So the Google Image Challenge was when Google released a massive data set of images, and nowadays simple classification is considered to be sort of older, sort of a more solved area, and so this was to put bounding boxes and then to verify the bounding boxes. So we had a team working on that and on our super-clusters, and they were able to place second place globally.
Wow.
On the Google image search for the classifications. So that helps us to push forward on and developing the new areas of Chainer and bring it into make sure that our computer vision is at the top level. Another competition that we, not a formal competition, but like a year or two ago, there was sort of a gentleman's competition to see who could have the fastest computation of ResNet. And to see who could do that the fastest. Before we tried, it was previously owned by Facebook using 256 GPUs, who did it in 1 hour to calculate to the one batch of ResNet.
Okay.
So we had 1,024 GPUs, and we're able to scale that straight linearly and do it in under 15 minutes.
Nice.
Wow. Very nice.
That's a ridiculous number of CPUs.
Yeah,
to just have. Or GPUs.
And the real challenge of it is if you've had a chance to work with superclusters, is that you think that it just linear. It's actually an exponential number of connections. The more nodes that you have, it's not a linear progression. It's an exponential number of connections you have between it to train basically the same model. And so they had to do a number of inventions. So we have, for instance, as another example, we have a package for that, which is Chainer MN, multi-node, which is specialized just to use Chainer and then to put it across to multiple nodes for doing high-performance training.
Interesting. Awesome. How many nodes does that scale to, just out of curiosity? Do you know?
Well, we haven't really maxed it yet, right?
Wow.
That's all the nodes we had. And now we've since then that we've upgraded actually some faster GPUs as well.
Sure.
And that benchmark has been further surpassed. I think I can't even remember what it's at now. It's since we brought it down to under 15 minutes now, it's become a couple of minutes that they're able to train it. And they're using also other clever technologies and other things to bring it even shorter than that. So the market continues to advance on, which is why we're excited about bringing Chainer X and then having a new capability that will enable us to keep up with the rate of progression of the GPUs that are out there.
That's really cool. I've been at George Washington University this week, working in the engineering building, and there's this whole robotics lab with the glass walls around it. And I couldn't stop but think when we were talking the other day about the robotics and the vision stuff that you're doing. And I think these real world applications are so cool. Maybe you want to share a little bit about that.
Sure. One of the projects for our company is to come up with personalized robots.
Nice.
Yeah.
So we've done some focus groups and other things, and what we found that we thought would be achievable within a few years, and something everybody wants is basically a house tidying robot.
Yep, everyone wants that. That can't
right?
confirm.
Right. So, I mean, you have your Roomba, but I'm not sure if you've had experience with one. I have one in my house, and it's great. But then you have this whole stage where now you're cleaning up for the Roomba to vacuum.
Right.
Right, so you have this pre-stage then where you go up and, okay, well, the Roomba's gonna, these clothes on the floor are not gonna work with the Roomba, and this thing needs to be put up, and I need to put up the chairs that are making, and other nice things, and get the pencils and pens off, or everything will get pushed around and I won't know where it is. So we did a demonstration at CTEC in Japan at the end of last year, where we had an HSR robot, which is manufactured by Toyota, that we had trained how to go around and pick up all the objects. We had, I believe, around 300 categories of objects that it was picking up. And we had it operating in this little, fake living room in the middle of a great, exposition hall and expo hall. And it ran for 5 days straight. We were really happy that we had our guys in the back room, but they had to do very little, actually. I think the most work that we did actually was continuing to dirty up the room because we had
made the humans work. Oh no. Have we lost him for a little bit? I know we're...
Did we lose your video there, Crispin? You still on? Oh. Sorry about the technical difficulties here, folks.
Yeah.
Maybe
one thing
can remove his stream and come back in. So
yeah. But I mean, one of the things, the surprise I had for you, Anthony, was I was texting with my daughter last night, and I was like, did you ever use something like Chainer? And she actually lives in Japan.
Right.
And she's like, oh my gosh, I use Paint Chainer or Paints Chainer all the time. And basically it takes like manga pictures or sketches.
Yeah.
And then it colorizes it. And there's like a whole demo that they've done. And
wow.
I can't wait to share it with college students and high school students, because it's pretty impressive how quickly it does it. And, I think, let me see if I can find it.
Yeah, I think I found the link here. I'll post it in the chat right now. This is pretty cool. Wow, that's really neat.
She said it recognizes bat wings and, swords and roses and kind of gets the colors correct on that. So
right.
It's pretty neat.
It seems like, yeah, that's pretty cool. Yeah, and you can sort of select a color palette and a place, and it'll start it'll colorize the whole image for you. That's amazing.
Yeah. I mean, I think that's one of the things with machine learning and deep learning is, I think, the applications of it, the models and algorithms and speed are cool, but as you get all of those things, you open up all these doors for other things that you can do.
Right. Yeah. And I think we've really only started to kind of scratch the surface on all those applications.
Absolutely.
I think someone had a news report today about how it's estimated that by 2022, 60% of businesses will be using machine learning or deep learning in some way in a user-facing manner that'll actually affect their customers, which is pretty interesting prediction. And I kind of wonder about the remaining 40% in that case.
They're the late adopters.
Yeah, they're the ones who are left
behind.
behind. Yeah.
Hi.
I'll see if I can find that.
Back.
Hey, welcome back, Crispin. Sorry, everyone.
We were talking about Paints Chainer while you were gone, just to entertain ourselves and
hear
others.
Yet.
Oh, you can't hear yet. Oh.
Oh no.
That's not good. Can you hear now?
It's like his connectivity is
Yeah.
Can't hear yet.
pretty
If you
low.
shut off the video, can you hear?
We can shut off the video. Can you
Can
hear
you
us now? Oh, nope.
Nope, nope.
We lost him.
Hmm.
Well, I think we'll give it a couple of more minutes. I'll probably try more time, but
Yeah, I had done a literature search, and there's some pretty cool stuff that they've been doing in the past couple of years. So it's worth putting down some of those academic papers.
yeah, for sure. No, and I think there's just a lot of activity in this area as well.
Can you hear me?
Yes.
Yeah.
We can hear
Can
you.
you hear us?
Let me say.
Okay, you can hear me. That's great. I can't hear you though.
Well, then you keep
All right.
talking.
Pardon. Just technical difficulties here. I'll just try shutting down and restarting.
Okay. All right. So a little bit of a chunk out of the episode here. Maybe.
Yeah. I also think one of the things that's cool that they do is with the industrial automation. I wanted to ask him at some point, like, are they doing parts verification? Like, you're on a manufacturing line and,
Right.
With the vision, or, is that something that's planned? Because I think a lot of, inspection of chips and whatnot would be pretty useful.
Very useful.
Okay.
Can you hear us now?
Yes, I can. Thanks.
Yeah, we can hear you too.
Perfect.
Welcome back.
I don't think my office has ever seen me move that fast.
Doesn't sound particularly Japanese necessarily.
No, it's not particularly me either. So apologies for that, and thanks for your patience.
We were just talking about some of the use cases in the real world for it. So we talked about paint chainer, and we talked about, we had just started talking before you connected about industrial applications and whether or not you might be seeing customers doing parts inspection or sorting of things.
Yeah, those are all things that we're interested in, and we're really interested in seeing Chainer used for. Part of the other side of it with Chainer X is that the C back end of it allows it to be more versatile in how it can be used. So the chainer on Chainer X is one way, and that gives the ability to do the development. But then also, now that the back end is written in C++, it can be exported to devices that don't even have Python.
That's right, all the embedded system stuff.
Right. So it feels like at this point in the world, we're getting to the point where models need to be deployed as well, and less scholastic, but more so that they need to be put out on devices, and small devices that might not have large computing ability.
Right.
So the exportability of it is one of the other key improvements we're looking for with Chainer X.
Yeah.
That's a really cool approach too.
Yeah, that sort of idea of being able to deploy small models to to embedded systems that are always on, I think, is very important going forward. So
and then also on the other side of it is the extensibility, is that Chainer X then covers more of the things that used to be done by CUPA and other things. And so for making a new backend, currently NVIDIA is leading the crowd by a significant margin as far as GPU usability. And we would also like to see AMD or FPGA or other available substrates. And step makes it easier then to take the next step to go to those other platforms.
Right.
Very cool.
That makes a lot of sense. At this point, I'd just like to remind everyone once again that if you are looking to get involved in Chainer and any of these things sound exciting, this is a great way to step in and either fund Chainer or step in and contribute code or get involved anyway. And before we wrap up our discussion of the roadmap, Carol, did you have any other questions, or Chrisman, do you have anything that you Wanted to get in right under the under the wire here.
Sure. One last thing, one more thing. The other thing that we're releasing with ChainerX actually is mixed mode 16.
Okay.
Mixed mode. So in the CUDA right now in NVIDIA drivers, it still largely requires you to use a 32, float 32 for batch normalization.
Yeah.
Mm-hmm.
Right, so we're implementing mixed 16, which then allows you to do most of the layer calculations in float 16, and then switches it automatically to float 32 for the batch normalization.
Right.
Interesting.
Yeah, that saves a lot on the computation time and model size and things like that, right? So
yeah, in our own company, we found about a 3 times speed improvement just by moving to mix 16.
Nice.
Wow,
Yeah.
that's a good.
Super linear.
Yeah.
Yeah. All right. Have you played around with like a mixed 8 or anything along those lines?
No, we haven't gotten that far yet, but it is one of the things to take a look at. But yeah. I'm sure that once we get through with it, once we've moved to this one, it'll probably be one of the next things. The jump from the 8 to the 32 might, not sure if that's going to cause some kind of impact in that area or not.
Yeah. Well, very cool. That's excellent.
Awesome. Anything else you want to share with us on the roadmap? Because I think you have your hands full, and it would be great if other folks could help you out and contribute.
Yes. No, those are the things we're looking for. Really, it's as an open source project, in many ways, we want to be driven by what the capabilities and things are that other people are looking for. Mm-hmm. So if there's an itch that you'd like to scratch, I think Chainer is a great place to start, and very accessible to using that to develop what it is your research or what your needs are.
Very cool.
Excellent. So at this point, we will answer any questions from our viewership. And it looks like we haven't gotten any from the viewers today. So I'll just ask a generic straw man question, and hopefully we'll get some in the next minute or so if folks want to ask. But what's the single coolest thing that you've seen done with Chainer?
The single coolest thing.
Yeah, what's the most nifty, neatest, or what's the thing that took you aback when you first saw it, maybe the most?
It was actually one of the things that I find hypnotic just to watch. One of the researchers here in our company, Miyato-san, came up with basically pushed the limits of GAN morphing and was able to do 1,000 category morphing for GANs.
Whoa.
Wow.
That's impressive.
Yeah, and so if you just watch the YouTube of it, you can just watch an image morph through like the butterfly, lighthouse, firehouse. It just goes through all the things. And yeah, I have to turn it off.
Wow, we'll put that in the show notes for sure.
Yeah,
that sounds
be a good
great.
YouTube thing to look at. It's sort of like watching the log on the fireplace or something.
Yeah. It just I find it fascinating and kind of entrancing, and so he can morph basically in any direction from any picture, and it has an inherent structure behind a randomization core, so that the pictures are always different. And then can do full loop, like go through like 1,000 categories and then morph back to the original picture. Which
seriously,
amazing. Oh, that's cool.
That's great.
Very cool. All right.
Well, so if there are no other questions, then at this point, we'll go ahead and dive into our world famous rant section, where we each get about 15 seconds to rant on whatever topic we want. Chrisman, it is your soapbox.
Okay, well, yeah, so this has been something that's come up recently. Like there was a time when we first started with the internet where you had a few websites and you tried to memorize the passwords for them because you were told it's bad to have the same password for all the websites. And then you had like these notes or something, but of course it's bad to have notes next to your computer or other things. And you had different passwords and things, and you started to get into the different requirements, right? Capital letters, small letters and stuff. And it was really irritating for a while. With the password managers, right? Either the keychain on Apple or 1Pass or 1Password or other things, where then for a while the problem was solved. You went to any website, it'd automatically fill in a robust password for you and you could just click into it. And I feel like we've gone in reverse now, because now when I go to a website, the first thing that'll come up is it'll say, authenticate with Facebook, authenticate with Google, authenticate with live identity, authenticate with password. And I have two Google accounts. I have my Gmail account for personal, I have my Gmail for work. And I have various reasons, and I really don't like to use any of them anyway, because I don't want to give additional information that I don't think these things did, although at one point I wasn't as worried about it. So now every time I come to a website, I'm in the same thing of going, which one did I use?
Yeah.
This website, right? And so now I'm going through like a number of Facebook. I've never authenticated this website before. Okay, no, it wasn't Facebook. Okay, Google. Okay, which Google would it be then? And then sometimes find out that no, I just entered a password on this one because it predates before these consolidators for authentication. So I feel like we're going backwards in the ease of using internet websites. And I wish we were just back in the one-click get onto the website.
Well, you need two-factor with multiple cell phones too, and then you'd be like really set.
Yeah, definitely.
Right. Yeah, as long as we're on rants. Yeah, the two-factor authentication is really like I have a computer at work and a computer at home, and then if I log into the computer at home, it'll be in a while, and then it's going to say, "Hey, are you really Chrisman? Thanks for that, but are you really Chrisman?" And then I have to wait for it to text my phone, and then watch my phone.
Yes, but are you really Chrisman?
Yeah.
I have to remember how I told them who I am, right?
Yeah.
Well, Carol, I think the soapbox goes to you at this point. So
yeah, and I think I'm going to continue on the website rant, and mine is actually the CAPTCHA stuff. We've been doing a lot of Google Forms and things this week, and hitting a lot of different sites. And I think Fernando Perez put it the best. It's like finding a needle in the haystack, in the haystack, in the haystack, in the haystack. Oh yes, and another needle in that haystack, and about 6 iterations through. Oh, you're not a robot. So yeah, so that's my rant for the day.
Well, thanks. For my rant, I would just like to say that Google seems to be slowly killing Inbox early ahead of schedule. They seem to just be taking away features slowly or having things not work and not really caring to fix them. And in my opinion, Inbox is not a Gmail replacement. So that being said, that's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including Chainer, you can find all of the project roadmaps at quansight.com/projects. Chrisman, where can people find you and Chainer?
So Chainer is available at chainer.org, and I can be reached at Chrisman at preferred.jp. I think we'll spell that so I don't have to spell it now on the blog or YouTube.
Excellent. Thanks. Okay. And join us again, everyone, next episode for a fluid discussion on TensorFlow.
Oh, another bad pun. Thanks, Anthony.